Look closely at this glowing mesh covering the Earth from orbit. It facilitates over 100,000 searches and millions of video streams every second, acting as the primary nervous system for our planet's data. But jump back to the 1960s, during the height of the Cold War, and global communication was dangerously fragile. Networks relied on centralized hubs. If a nuclear strike wiped out one main hub, the entire surrounding system went dark. This diagram shows ARPA's radical engineering solution to that vulnerability. Instead of a vulnerable central hub, the U.S. Defense Department proposed a decentralized network. If one node was destroyed, the data would simply route around the damage to reach its destination. This theoretical defense system faced its first physical test here at the University of California, Los Angeles, in the fall of 1969. Inside a lab much like this one, researchers were attempting something unprecedented, forcing massive, completely isolated mainframe computers to speak to one another across a physical distance. A programmer sat at his terminal and typed the command login. He transmitted the letter L, then he transmitted the letter O, and then the entire system completely crashed. The connection held together for exactly 2 letters. Yet that brief, imperfect transmission proved the core concept. A remote, resilient connection was scientifically possible. Over the next 2 years, the physical network rapidly scaled. By 1971, 15 nodes connected major universities across the U.S., and by 1973, lines reached across the Atlantic. But this physical expansion created a massive software crisis. Different universities and labs used completely incompatible computer systems, and none of them spoke the same digital language. The network was tearing itself apart into isolated fragments. 2 visionaries, Vint Cerf and Robert Kahn, engineered a solution called TCP/IP, or Transmission Control Protocol and Internet Protocol. You can think of it as a universal translator for data. Instead of sending one massive file down a single pipe, TCP/IP breaks data into standardized packets. These disperse, taking chaotic pathways through the network. Upon reaching their destination, the protocol perfectly reassembles them. The specific hardware used no longer mattered. On January 1, 1983, every single machine connected to the ARPANET officially adopted this exact protocol. By forcing incompatible machines to finally understand each other, those fragmented academic networks fused into a single cohesive global entity. This unified standard was the true birth of the Internet. Even with a unified network, the 1980s Internet remained entirely inaccessible to the general public. Navigating it required deep knowledge of raw computer code. In 1990, a scientist named Tim Berners-Lee was tasked with solving this usability problem right here at CERN, the massive physics research lab in Switzerland. This diagram shows his revolutionary invention, the World Wide Web. He layered a system of visual, clickable hyperlinks directly over the raw, unreadable code of the Internet, creating a web of pages anyone could navigate. The result was exponential. In 1990, the entire world had exactly 1 website. Within 3 years, that number exploded to over 600. The World Wide Web acted as the crucial translation layer. It allowed the Internet to escape the confines of the military-academic complex and finally enter the public domain. By the late 1990s, the public was eagerly buying physical hardware, like this 56K dial-up modem, to connect their home computers to this new digital space. This access rapidly shifted global culture. It pulled people out of their isolated physical routines and pushed them into shared digital environments for the first time. In the year 2000, 400 million people were online. By 2010, that figure surpassed 2 billion. The same system built to withstand nuclear war now handles over 300 billion emails every day. It serves as the foundation for global banking, video streaming, and the development of artificial intelligence. Every modern digital service traces its roots back to that failed 1969 login attempt. Those first 2 letters, L and O, evolved into a network that now connects more than 5 billion people.